Hello, yeah, in this video, I want to share with you an R function that compute descriptive statistics for all variables in a data frame. So this offers a quick and dirty way to look at the descriptive statistics of all variables in a data frame. So here's the small R function. You can see it requires two arguments. The first one is df, is the data frame you're analyzing. So the m is the integer. It is the number of levels beyond which the variable is considered to be continuous. Commonly used values for m can be like 5 or 7. So basically, in your data frame, there may be values that are continuous. They will take values like real numbers with decimal points, or they can be categorical. For example, they can be 0, 1, or 1, 2, 3, 4, 5. So a kind of a commonly used rule of thumb is if the levels of a categorical variable goes beyond 7, we kind of treat them as a continuous variable. Okay. So this function requires you to give the data frame, and also it specify the number of levels you want to determine whether a variable is continuous or categorical. Okay. So the idea is to first just change the classes of all variables into a factor. So basically, first get all the names of the data frame, and then just convert everything into factor. And then we want to determine the levels of these factors. And then if the levels of the factors is larger than m, then we call this column is a numerical column. And then we just go back to the data frame to change the class of the variable on these numerical columns, change their class back into numeric. Then after that, we just load in the library prettyR and just using describe of df. So describe function will automatically generate frequency tables for categorical variables and mean and standard deviations for the continuous variables. Okay, so first let's just read this into R. Now I'm giving a couple of examples. The first, there's a built-in data set in R. For example, the well-known ARIS data set. It has 150 rows and 5 variables. So you can see 4 are numeric, 1 is species factor. So we can just put in, say, f.prettyR ARIS and m equal to 5. So you can see it automatically generate descriptive statistics for the numerical variables, mean, median, variance, standard deviation, valid, n. Okay. And then has for the factor to generate the count and percentages. Okay. All right. The next example I want to use is the empty cars. This has 32 rows and 11 variables. And these are the structure of the data frame. You can see all the variables are numeric here, but obviously some variables has like 0, 1, or, they may not have many distinct values. So here I choose m equal to 7. So you call that function. It automatically generates the frequency tables and the means and standard deviations for the continuous variable. So here, okay, so it treats like these variables as continuous, and then the other ones, even this carb, because it has I think 7 categories as count as a categorical variable. All right, the last example, I want to use a data set in the library DAAG. It's called rock art. So you can see it has 103 rows and 641 variables. So here I still choose m equal to 7. And you can see it automatically generate all the counts. It treats many variables as categorical. It does have a lot of categorical variables. Yeah, so it's very long, so it has more than 600 variables. So if we take a look at rock art, so you can see it has a lot of variables. As the first few, let me see here. Yeah, like this maximum weight, height, and this looks like numerical. So as you can see, this function works on various data sets, and I hope it can be a good tool for you to quickly compute all descriptive statistics in a data set. One immediate benefit for generating all these descriptive statistics is you can, for example, if you look at the continuous variable, you can look at their standard deviations. If standard deviation is very, very small, or you look at the categorical variable and it's highly imbalanced, it also means the variability is very, very low. Then those variables cannot be assessed for their effects on the outcome because you don't have much variability. Okay. All right. Just trying to provide more tools for quick data analysis. Thank you.